if you're watching today's lesson, today is 312, and we're going to do some problems involving work. So we're using this equation. And again, Ella, I know you were out yesterday. Your partner there, Andrew, might have some notes for you. I don't think I recorded yesterday's, unfortunately. But this is the equation that we're going to use. Okay. Positive work versus negative work has to do with whether or not the force is in the same direction as the motion or opposite the direction of motion. And so let's go ahead and I'll put some numbers to this equation. Two athletes, Bob and Tom, push a 250 kilogram sled. Each pushes with a force of 150 newtons. But Bob pushes for 10 meters and Tom pushes for 12 meters before jumping in. Now on this bobsled, there's two people. Which one do you think is Bob? Which one do you think is Tom? Just look at the story, look at the picture. Which one do you think is which? Tell that person that you're sitting next to. Is Bob the one in front or the one in behind? And how can you tell? Take a moment. Anyone want to take a guess? You want to try it? It's just a guess right now, but can you tell that they push for different distances?
One on the right.
The one on the
right is Bob.
On the right, the one that's in front?
I can't tell.
Okay, so the sled is coming up towards you, right?
Yeah.
You have one person pushing on the right of the sled, which I guess would be like the left of the sled if you're coming up. But they push there. The other person's in the back. Who pushes longer, typically? The person in the front or the person in the back? For a bobsled? The back, yeah. So what happens is they're pushing along, they're trying to get the sled as fast as they can, and so the one in the front would jump in, and then the other one would just keep pushing a little bit longer and then jump in. Okay, so Bob and Tom, if you're interested in knowing who's who, that's where they are. Now, while one pushes for longer than the other, they both push with the same amount of force, and would you guys agree that force is in the same direction as the bobsled is moving? You're doing positive work. Now, while they're doing this, it is not quite frictionless. So there is a little bit of friction between the ice and the sled rails. So that friction of 25 newtons acts the entire 12 meters. Our goal here is to quantify how much work was done by three things: Bob, Tom, and friction, or ice, if you will. Okay, so we're going to use that equation. Now, I'm going to be very explicit with my writing, meaning I'm going to write a lot up here. You might not need to write everything that I'm doing, but you should show some work. Literally and figuratively. So I'm going to write the work done by, let's do Bob first. The force that Bob exerts multiplied by the distance that Bob exerts that force. Because they're aligned with each other, I know that work is going to be positive. So let's see. Bob pushes with 150 newtons. He pushes for a distance of 10 meters. And when we multiply those two numbers together, it'll be at 1,500. Now, refresh our memory from yesterday, because we have to put some numbers. We're quantifying work now. 1,500 what? And you look at that and you say, well, it's a Newton multiplied by a meter, so that'd be Newton meters. We could say 1,500 Newton meters or 1,500 joules. So the amount of work that Bob does, 1,500 joules. Now, Tom, person in the back, he pushes for a little bit longer. So I'm, again, being very explicit with my writing here so that I know who's doing that work. He pushes with 150 newtons. He does that for 12 meters. Now, you might need to use a calculator for this, but try not to do it. Do you see that it's 2 meters further than Tom or Bob? Well, 2 meters with 150 newtons each is another 300, right? So if Bob did 1,500 joules, Tom is doing 1,800 joules of work. Now, you could use a calculator if you'd like to. But sometimes you can just sort of reason through with doing some math in your head. Now, there's also the ice that's doing some work. And so now what I want to do is I want to do the work done by the ice. And that's done through friction. multiplied by the distance that friction acts. And the challenging part here is to recognize which way friction acts in relation to the way the sled is moving. And so it doesn't say anything on here about the direction, but you should infer from this that friction, you guys know friction always opposes motion, correct? So that friction is doing negative work. And so that negative work, I could write that in as a negative 25 multiplied by 12 meters. And when I do that, let's see, 250, another 50 on that, is that 300, is that negative 300? Okay. So again, negative 300, you might use your calculator for that. Now what I'm interested in is the total work. So if I have three things that are doing work on this, then I would just simply add them up. And so the work that's total, and I'm going to use a notation that you guys have seen before with a sigma. Sigma means sum of the work done. I add those things up, and what I get is 15 plus 1,800, that'd be 3,300. Take away 300, I get 3,000 joules. And so the total amount of work is 3,000 joules. Now my question for you is this. If work is a transfer of energy, and that's what this is, my question for you is how much energy does that sled have, you say, at this point? It was at rest, so it doesn't have any energy of motion. After this, how much energy does it have? You'd say 3,000 joules. Because the effect of that work was to change the energy of that sled. Okay? Raise your hand if you've done any bench pressing before, you've ever laid on a bench and done some weightlifting kind of stuff. Just a few people. All right. So imagine, let's see, Jesse, could you go grab me a meter stick? The next problem we're going to try is a bench pressing kind of thing. And so imagine I'm laying back on the bench, and I'm laying down and I'm doing this here. What kind of work am I doing as I lift it? Positive or negative? Positive. How do you know? It's going up, but so is the force that I'm exerting is upward, right? So when I lift this thing, if I'm laying on the back, laying like this, and I'm doing this, I'm doing positive work. Now, while I'm lifting it, something else is doing negative work. I want to see if you can figure out what that is. What's the other thing that's doing negative work? What is that thing that's doing negative work as I lift it? The weight. No, not the. Thank you for trying. Not the weight. There's something else that's doing negative work. I'm doing positive work. We said that. I'm exerting a force in the direction that I'm moving that thing, so I'm doing positive work. But something else is doing negative work. Turn to the other person that you're sitting next to. What do you think that is that's doing negative work on this thing as I lift it? Okay. So imagine I'm laying back and I'm doing this. What's doing negative work? Oh, it's the weight. But gravity is not a thing. Gravity is a force, but it's not a thing. So I'm doing positive work, but something is doing negative work. And it's the force that's doing negative work is gravity. But what is that thing? And that'd be the Earth that's doing it, right? So the Earth is doing negative work on it. And that's because the force that the Earth exerts on that is downward as it's moving up. Okay. Now we're interested in how much work the weightlifter does. So as he's lifting it, he's applying a force this way. And the distance that this thing moves is this way. He's doing positive work as he lifts it. Now, because the weight force due to gravity is downward, I notice that while that thing is being lifted, there is a weight that's acting down. And that's from the Earth that's going down on it. You notice that when he applies an upward force, the Earth exerts a downward force. He's doing positive work. The Earth is doing negative work. How about when he lowers it? Let's just try this really quick. Just to understand the idea of direction of force. I just lifted this thing up, and now I'm going to lower it. As I lower it, am I doing positive or negative work on this thing as I lower it? Turn and tell that person that you're sitting next to whether or not when I lower it, I'm doing positive or negative work. turn it on. As I lower it, positive or negative? What do you guys say back there?
I said positive.
Okay. If it's positive, while I lower it, then that would mean I would be exerting a force in the direction that it's moving. If I were doing that, it'd be like this. I'd be like throwing that thing down. Which way am I exerting force as I lower it? Which way am I exerting force? You guys agree it's still up? If it were down, that would be like pulling that thing down. So what I'm doing is I'm doing negative work on this object as I lower it. And the reason I know that is that the force I'm exerting is up and the motion is down. Now, while I'm doing negative work, what is doing positive work on it? The Earth, through gravity, right? So which way, guys, it's the important part of it, you can multiply two numbers together. What you're going to have a hard time with is knowing whether or not that work is positive or negative. And you have to look at the direction of the motion in relation to the direction of the applied force. So, I mean, that's a key thing. Because we can multiply numbers. Knowing which way they act is the important part there. All right, so let's go ahead and do this now. So I want to know the work that, how much work is done on the barbell by the athlete. So the work done by the athlete is equal to the force. Let's change the color here so that it is matching what I have up here. So the work done by the athlete is equal to the force the athlete exerts, multiplied by the distance that the athlete exerts that force. While he's lifting it, he's exerting, well, what do I put in here? The 100, the 220, or the 1,000? It's a 100 kilogram dumbbell. It's about 220 pounds. How do I go from 100 kilograms to 1,000 newtons? If we say G is about 10 newtons per kilogram, then the force that he's exerting is about 1,000 newtons. Okay, 40 centimeters. If I want to have joules out of this, I have to put in the appropriate unit for that. So I wouldn't put in 40. I'd put in 0.40 meters. So while he's lifting that, he's doing work of about 400 joules during that lift. Okay? Questions for me? Okay, I'm not going to go any more detail on that. I'm going to give you guys some problems to try. One of them involves, though, an activity. I'm going to have you start with the activity. And then you will, after you finish up that activity, then I'll have you work on some other problems here. So what I'm going to need from you is I need to have your tables cleared off a little bit. I have to get some equipment out for you. And so you're going to have to get these things to your table, and then from that you can then do some of this work. So could you have the oldest person, please, at your table? Oldest person, come and grab one of these for everyone. So everyone's going to need one of these. Oldest person. Youngest person has to come back and see me back here. So youngest person, come back here.
When's your birthday?
We need one of those. Next, middle-aged person, come back here. You're going to need some of these. So in the middle group, you're like, oh, I didn't have to do anything. You need to come and see them. You need one of these. All right, and the person who hasn't done anything yet, because you're like, oh, I haven't done anything yet, you need to come and see me because there's another thing you have to get. This one, yeah, this one. And yet, someone else that maybe hasn't done anything yet, well, maybe you guys all have, you need to come and see me because you need one of these. So I'm gonna get you doing some work today, literally and figuratively. You need one of those. Okay. Now, the very first question I'm gonna have you guys do, let's see. Equipment needed, a block of wood right here. You have a Newton scale. Make sure it's calibrated so that it reads 0 to begin with. So again, you guys, I can't remember, did I have you guys do anything with these? You guys measured a couple of things with these. Sorry. So Newton scale to measure force. You have a meter, 1 kilogram mass, so that's going to go on top of this thing. You have and a meter stick or ruler. So the meter stick, I would make sure your measurements are all done on the metric side, not on the English side. So metric side. And then it's going to ask you to make some measurements here, and then you have to do some calculations based on number 1. Once you get through number 1, I want to see the answers. 2, 3, 4, 5, and 6 can be done without equipment, but I want to get number 1 done first. I want to see how you guys did on that. Okay? So you work together on number 1 to accomplish that task. And then once you're done with that, you can work on the others. Call me over when you're done. I want to see your answers to number 1. Okay? Go.